So now that we know what the central limit theorem is and we know how to use it, let's go ahead and work some applied problems. This first problem involves a fundraiser where we want to book a room, but we might not want to book a huge room. It might be really expensive if you're at a swanky hotel, right? But you also don't want to book a room that's too small because then you'll be overcrowded. So in this case, we send out 1,000 email invitations, right? So we have these 1,000 people here. And we know that on average, based on past fundraisers, 12% show up. So we know that in this whole population of everyone we could email, okay, pi is 12%. And I take this sample of 1,000 people, so if the thousands of my sample is not my population. Okay. And of course, there's going to be some percentage in that sample that show up. And I want to know what size room should I book so that there's only a 5% chance I have more guests than I have room. So let's let X room be equal to the number of people that the room can accommodate. Okay. And X actual is the number of people that actually show up. And what I want is I want the probability that the number who actually show up is greater than the number that will fit in the room to be 5%. Okay? Now if I divide by the sample size, so my sample size here is 1,000, right? So I'm gonna divide here through by n. Make that actual, okay. This is some unknown value, but this is what I actually see. So this is the probability that pi hat is going to be greater than some unknown value. Okay? I don't know what this value is. This is the percentage of people this is the percentage of people who were invited that will fit in the room, okay? So notice what this value is. This is a variable, right? I don't know what pi hat is. Pi hat here is actually a variable. This is the 5th percentile. So this is the 5th percentile for the sampling distribution, right? This makes sense. This is, well, actually this is the upper 5th percentile, right? So the probability that a sample proportion is going to be greater than a specific value being 5% means that this is the upper 5th percentile for pi hat. So the question is, what is the distribution of pi hat, right? If I'm going to compute a percentile, I have to know what the distribution for that variable is. So I know in this case that pi hat has a normal distribution. The mean is the population proportion times pi times 1 minus pi over n square root. And I'm going to go ahead and I'm going to substitute these values in, right? So pi is 12% and n is equal to 1,000. And so if we put this in Excel, let's go ahead and put this in Excel to see how this is going to work. So here I'm working with pi hat, and I want to go from a percentile to a data value. Okay, so my sample size here is 1,000. I'm working with the fifth upper percentile, so I'm going to have to convert it to a lower percentile. The population proportion is 12%, and the standard deviation is the square root, and it's going to be pi times 1 minus pi divided by the sample size. Make sure that you have all of your nested parentheses balanced, okay? And I hit enter. Now I want the data value for the 95th percentile. And let's just kind of sketch out what it is that's going on here, okay? So notice that roughly it's 12% and the standard deviation is 1%, okay? So if we kind of sketch out what's going on with this distribution. So the percentage of people that we expect to show up, this is roughly 12% and 1%. So of course this is 12, 1, 2, 3, 1, 2, 3, 13, 14, 15, 11, 10, 9. I'm stepping out in units of standard deviation, right? And I want the value, I want the sample percentage that basically is going to be in the 5th percentile. So I want this value here that has 5% in its upper tail. Okay. So let's see how this is going to work out in Excel. So I'm going to have to use norm.inv because I'm going backwards, right? So I'd use norm.inv. My percentiles, my probability. This is my mean. And this is my standard deviation. So this tells me that if I book a room that can hold 13.7% of the people that I invited, there's only a 5% chance I'm going to get more than that percentage. So let's just go back for a second and look at this. So 13.7%, there's only a 5% I'm going to get more than that. So what should the capacity for the room be? So I know that the number in the room divided by n is equal to 0.137. And if I multiply both sides by n, which is 1,000, right, then the capacity of the room has to be 1,000 times 0.137, or 137. So if I book a room that can hold 137 people, there's only a 5% chance that I will not have enough room, that more people will come than I have room. All right, good. So this is a really common sort of calculation that people do in business. They send out a lot of flyers, a lot of announcements, a lot of invitations, and they have to do these sorts of calculations. Let's switch gears now and look at a problem involving a quantitative variable. So I'll let you stop the video and read the problem. Okay, so we want to know what is the probability that if a doctor takes a single blood pressure reading, you're going to be diagnosed with high blood pressure? Okay, and this is what stage 2 hypertension is, by the way. Okay. So what do I know? Well, I know that blood pressure has a normal distribution. I'm told the mean is 120 and the standard deviation is 10. And I know that the distribution of blood pressure is normal because it's a physiological measurement, right? So if I think about what this distribution looks like, I'm just going to sketch this out. So if you pick a healthy individual from the, well, if you just pick a person from the general population, we're not stipulating they have to be healthy, but the population from the blood pressure from a randomly chosen person in the population has this distribution. So a person is diagnosed as having high blood pressure when their blood pressure is 140. So the probability that they're going to have a blood pressure higher than 140 is the area in this left tail. And of course we can figure that out using a straightforward normal distribution calculator. Now we know that norm.dist, which is what we're going to use, right, is going to give us the area in the lower tail. So I'm going to have to subtract it from 1 to get the area in the upper tail. So let's go ahead and try this with our Excel sheet. So if we go to our Excel sheet, now we're looking at mu hat, right? And I'm giving a data value and I want the percentile. Here my sample size is just 1, right? And my mu hat is 140. So when you take a single value, right, the mu hat is equal to the value that you're looking at. And of course this is 120. Standard deviation is 10. And this is going to be equal to, so this is the standard deviation of mu hat. It's the standard deviation of the variable divided by the square root of the sample size. And in this case it's trivial, it's just going to be 1, but I can change that, of course, for other problems. And I want to know what is the percentile of mu hat, right? So I'm going to say it's 100 times norm.dist. The data value that I want the percentile is 140. The mean is 120. The standard deviation is E3. I'm going to have to enter that, unfortunately, by hand. That's okay. And then true. Make sure. B3, C3, E3. Yeah. So that's going to be my percentile. And I know that's pretty close to being correct because just with the empirical rule, you could figure out that that's 97.75. So that looks good. The upper percentile is just going to be 100% minus the lower percentile. And so this is the value that we want. There's only roughly a 2.3% chance that a person in the general population will be diagnosed as having hypertension. So this is what equal to about 2.3. And of course on the homework, it'll ask you to round it off to the appropriate number of decimal places, and that's all you have to do. Good. Now, what very often happens is people go to the doctor and they get what they call white coat syndrome, right? They get kind of anxious, or maybe they're upset because they have to wait so long. And so what a doctor does to ensure that one reading doesn't throw things off is they take the average of a couple of blood pressure readings. So suppose you're from the general population and a doctor takes 4 blood pressure readings and then averages them. Now the question is, what is the probability that the average of those 4 will be above 140? Okay? And so if we look at this, notice things are going to change now, because the average blood pressure reading is going to have a normal distribution. The mean is going to be the mean of the blood pressures, which is 120, but the standard deviation will be 10 divided by the square root of 4. So this tells us that the average blood pressure reading has a normal distribution, the mean is 120, and the standard deviation is 5. And so if we compare these two distributions, okay, this is blood pressure, and this is going to be average blood pressure. They both have the same mean, but average blood pressure has a standard deviation of 5. So its distribution looks like this. And so now if we take the percentile of 140 in this distribution, we're essentially 4 standard deviations away. We expect we're going to get a really small answer, right? So if we now ask the question, what is the probability that the average blood pressure is going to be greater than 140? Again, I can use Excel for that. And in fact, all I have to do really is just change the sample size, right? I mean, everything else is the same on the spreadsheet. So if I simply change 1 to 4, everything else automatically updates. Notice that the value I want the percentile of is the same. The mean is the same. The standard deviations of the variable is the same. The standard deviation of mu hat is going to automatically change when I change this, and everything else will change too. And notice this value is really small, okay? It isn't 0, but it's a very, very small value. And if I put some more decimal points on that, more decimal places on that, you can see that this is in percentage, okay? You can see that there's only a 0.003% chance that a person is going to have an average of 4 blood pressures that's greater than 140. So that's one way that insurance companies kind of, help ensure that your blood pressure really is high. They take averages, and the averages are much more tightly clustered around the actual value. Now it says your insurance company will only pay for treatment if the average of the 4 blood pressures is in the upper first percentile. Okay, so the idea here is that we want to find the value that's in the upper first percentile. So there's some value here such that the average of the 4 blood pressures, the probability that it's greater than that is only 1%, and I want to find that value. Okay. So we're going to use norm.inv. If we go back to our spreadsheet here, right, we have 4. It's an upper percentile, so we're going to have to convert it to a lower percentile. Again, the mean's 120. Standard deviation is 10. Standard deviation of mu hat, it's the same formula, right? Standard deviation of the variable divided by the square root of the sample size. Okay. And now I want to find mu hat. So now I use norm.inv. So I say, given the 99th percentile of a normal distribution with a mean of 120 and a standard deviation of 5, what is that value? So it turns out that if the average of your 4 blood pressures is above roughly 132, your insurance company will pay for your treatment. We say 6'3", yeah, 6'3". So hopefully with the template that kind of helps you organize your work, and with these videos you have an idea of how you want to proceed.